In this video, I'll be helping you with the ALEKS problem type called solving a 3x3 system of linear equations, problem type 1. In this example, we're given this system of 3 equations and 3 variables and asked to solve for x, y, and z. And the method that I'll be using here is elimination, and I'll start by numbering or naming each of these equations. So we can call the first one equation 1, the second equation 2, the third equation 3. And for elimination, our goal is to add either these equations or multiples of these equations to eliminate variables. And I noticed that these first 2 equations have a 2z and a negative 2z, so I can see that adding equation 1 and equation 2 will cancel the z term. So lining up those 2 equations and adding 1x plus 2x gives me a 3x, 1y plus 1y, a 2y. As we intended, the z terms cancel, and minus 3 plus 4, a 1. So we have this new equation that has the z term eliminated. So for our next step, I'll want to again eliminate the z term, but using different equations. So instead of using equations 1 and 2, I can use 1 and 3, but I will need to multiply the third equation by 2 in order to cancel the z terms. So we'll have equation 1 plus 2 times equation 3. In rewriting this, I'll go ahead and multiply equation 3, every term, by 2. So equation 1 would be the same, and then multiplying through equation 3 by 2, 2 times x, a 2x, 2 times a 2y, a plus 4y, 2 times a negative z, a negative 2z, and again I set it up this way so that I can see that these will cancel when I add. Lastly, 2 times 5 gives us that right-hand side, a 10. And so adding here, 1x plus 2x, 3x, 1y plus 4y, a 5y. As intended, the z's cancel, and negative 3 plus 10, a 7. So the equation we have here is 3x plus 5y equals 7. And from here, we have 2 new equations that have had the z eliminated. So we've moved from a system with 3 variables and 3 equations to now having a system of 2 variables and 2 equations. And from here, I can continue to simplify with elimination, and I can see that I could almost eliminate the x's just by addition if one of those were negative. And I can make one of those negative by just multiplying that equation. And again, I could have chosen either one by a negative 1. So taking that first equation, 3x plus 2y equals 1, and then this bottom equation, multiplying through by the negative 1, would be a negative 3x minus 5y, and then equals a minus 7. Adding from here, we intentionally set this up to cancel the x's, and we now have 2y minus 5y, a minus 3y, equals 1 minus 7, a negative 6. And from here, I can solve for y completely by just dividing both sides by negative 3, leaving me y equals a positive 2. So we found our first value, y is 2. And then working back through these equations, I should be able to find the other values. I can plug this y value into one of these 2 equations to find x. I'll use the top one. Replacing y with 2, we would have 3 times x plus 2 times y, but y we now know is 2, equals 1. Solving for x, 3x plus 4 equals 1. Isolating the x, we have 3x equals negative 3. Solving for x, by dividing through by 3, we have x equals negative 1. We've now found a second value. X is negative 1. And now that we have two values, we can go back to any of those original 3 equations that have all 3 variables, substitute in this x and y, and be able to solve for z. Again, it doesn't matter which one we use, so I'll just use the first one. Replacing the x and y, we would have x we now know is negative 1, plus y, which we now know is 2, plus 2 times z equals minus 3. Solving here, negative 1 plus 2 is 1. Isolating the z, we would subtract over the 1, giving me a 2z equals negative 3 minus 1, a negative 4. And solving for z by dividing the 2 on both sides gives me z equals a minus 2. So we've now identified all 3. Z is minus 2. We've solved for the system of linear equations.